Good morning. Maing buntag.
Morning, ma'am.
Okay, so we will continue with our discussion on potential. So last time, our example is we had the spherical shell. We also have the solid sphere. So take note. Okay, so take note that for a spherical shell of radius r, the potential inside and outside is equal to, so you have V of R is equal to 1 over 4 pi epsilon naught Q over R. So this is inside, this is zero, no? Although the electric field of the inside of a spherical shell, so kung naka-spherical shell which is hollow inside, magbutang ka og kung diri ka mag-hug point to get your potential, the potential inside is equal to 1 over 4 pi epsilon naught Q over R. Okay? And anywhere ani nga surface sa imo ang, for example, magdraw ka diri og Gaussian nga surface, any point diri as a surface kay equipotential. So we call this equipotential surfaces. Okay? So take note that our reference point is from infinity, and then we would want to take, or we would like to uh, move a charge from this point gikan sa infinity padulong diri ang point. Okay, so the potential that this charge will experience is equal to this one kung naa siya sa sulod. uh, for points outside, say for example diri, if you want to take this charge here padulong diri point P, then V of R is equal to 1 over 4 pi epsilon naught Q over R. So your R here is the radius of the shell, and then your small r is the location of the point P. So gikan diri sa center, padulong diri, this is your R. Okay, so R is any distance from the center of the shell towards the point P. Okay? And then for a solid sphere, again with radius R, so this time, dili na siya hollow, no? Dili hollow imong sphere. So the potential, okay, inside, the potential inside is equal to, so ang potential inside class. Sa ganito, atong nakuha, the potential is one over 4 pi epsilon naught Q over 2R, and then we have 3 minus R squared over R squared. Okay. So sa to ang notation last time, wala na to gipagawa si 2, kining 1/2 diri kining 1/2 diri ang factor. So atong pagkasulat sa inyong notes class is 1 over 4 pi epsilon naught Q over R, and then you have here 3 halves minus R squared over 2R squared. Okay, wala na to gi-factor out. Wala na to na factor out si 2. So this is inside a solid sphere, and then outside it is just like that of the spherical shell. So it is equal to 1 over 4 pi epsilon naught Q over R. Okay. Ito ba? Yeah. So this is outside the sphere. So mula lang siya, pareha lang siya sa point charge. So if you can recall, kung naka electric field of a point charge, you can easily get the potential, and the potential is just equal to this one. All right, and then in our next example, we will have the potential. So this is another example, problem 1 for this meeting. So find the potential at distance s. So from an infinitely long straight wire that carries a uniform charge density equal to lambda. There's a uniform line charge, lambda. And then compute the gradient. Compute the gradient of your potential to check if it yields the correct field. Okay. Okay. So first, we need to get the electric field of this system. So nata na ni siya sa previous example pero wala na to na discuss. So we have this one. Discuss ba na to class electric field? Nakuha ba na itong electric field sa infinitely long straight wire? Nakuha na to, no? Okay, so sa to electric field sa infinitely long straight wire. So naka-infinitely long straight wire here. And then this has cylindrical symmetry. So nag-drawing ta Gaussian surface with radius S. So it has a radius S and a length L. So take note that your system is an infinitely long straight wire. So murag walay pulos no kung atong reference point, kung magkatag potential atong reference point is infinity. Okay, so we cannot do that. Okay, so first we have to get the electric field using Gauss law. So we have the electric field dot with the infinitesimal area. So integral of the closed integral of E dot dA, this is equal to Q enclosed over epsilon naught. Here, our Q enclosed, so our Q enclosed class, since it has a uniform line charge, our Q enclosed is just equal to lambda multiplied by the length of the wire. Okay? And then, the length of the Gaussian surface. And then your DA, naman, diri man to magkuha, no? So this is our surface. So S is constant. S is constant. So our DA is in terms of Z as well as phi. So we have S d phi dz, where S is a constant, where S is equal to S, or it is a constant. Okay. So we have here E, and then we can take E out. Kaya ano ganito? Parallel sila, no? Parallel sila ni DA. So, your electric field lines will emanate diri paana sa body sa imong cylinder. Okay, so diri ang direction sa imong electric field. And then, kung electric field diri amang gawas, dili siya, wala kay flux diri ang surface at the bottom and the top of the cylinder sa imong Gaussian surface kay ano ganito perpendicular ang area vector ug ang electric field vector. So dili lang ta sa body maglantaw. And then take note that E is parallel to your DA. So imong DA kay diri man pud siya padulong. This is your DA vector. Therefore, we can take E out and then we have we can also take S out since it is a constant. So we have D phi dz is equal to your Q enclosed is equal to lambda times L divided by epsilon naught. Okay, so ES, and then we have, this is double integral. So, this is d phi from 0 to 2 pi, and then your dz is from 0 to L. 0 to L. Okay, and then we have lambda L over epsilon naught. All right. So here, we see that, dili lang nato isulat kas ha. So E times S multiplied by 2 pi. And then here we have L minus 0, so that is L equals lambda L over epsilon naught. So we have E multiplied by 2 pi LS. Or this is just equal to the circumference, 2 pi r, of the base multiplied by the length. So, unsa gani ni siya class? Volume ni siya? Dili no? Area, surface area, 2 pi ls. This is equal to lambda L over epsilon naught. So we have E, the electric field, is equal to lambda L over 2 pi L. We have 2 pi here, and then Ls multiplied by epsilon naught, or this is just equal to lambda divided by 2 pi epsilon naught times S. Okay, so this is the electric field, and this is directed towards the radial direction. Radial, wala pa ng tawagan niya. Okay, so S hat direction. All right. And then after this, we will get the potential. So take note of this electric field class half for an infinitely long straight wire. Again, for infinitely long straight wire, infinitely long straight wire, the electric field is equal to lambda over 2 pi epsilon naught times S. Or sa uban nga mga books kay R ni siya ang ginagamit diri. Okay, S hat. So this is the electric field. And then next is to find the potential. So since the charge extends at infinity, so imo ang system no kay infinitely long straight wire, we cannot set the reference point at infinity. So we just set it, or let us set the reference point at A. Okay, so at A. So that V sub S, or V as a function of S, This is equal to E dot dl. If you can recall, this is our expression for the potential in terms of the electric field. So this is equal to the negative of, so your dl here is ds. Okay, so you have lambda 2 pi epsilon naught s in the radial direction. Ang ato pong DL class, di ba na tulo ka component sa DL, TSS hat, na kay D, Phi hat, and then DZ, Z hat. So since our electric field is along the S hat direction, then ang survive diri sa atong DL is katulang DSS hat. Okay, so you have DS here. All right, and then we integrate this in terms of S. So we have ang ato ang limit die class is from A towards S. Okay. So from point A towards S. So we cannot set it at infinity since the line or the wire is extended at infinity. So we have A to S. So we can take lambda over 2 pi epsilon naught out of the equation, the integral. And then what is left is you have this one, ds over s. Okay, so yung integral ani class? Ln, no? So nakay negative lambda over 2 pi epsilon naught, then ln of, so this is from a to s. So you have ln s minus ln a, that is s over a. So this is the potential. Okay, we will then check. So in order to check class, we just have to get the gradient of V. So the gradient of V is equal to, you have the partial derivative with respect to S of V plus, so this is S hat, partial derivative with respect to phi, and this is, I think, dili na siya mo survive nga kuan class nga term since atong wala tay phi, wala pod tay zeno. So Esra ang V is in terms of S lang. So let us see, V is in terms of S lang. So the other two components will be 0. The partial derivative of V with respect to phi is equal to 0. The partial derivative of V with respect to Z is also equal to 0. So we have this one. Partial derivative with respect to S of your V. So nakay negative lambda over 2 pi epsilon naught. And then you have ln S over A. Okay. And then you have your direction here, S hat. So we can take the constants out of the derivative. So nakay negative lambda over 2 pi epsilon naught. Partial derivative of ln S over A. So hanggang ini siya class. So nakay negative lambda over 2 pi epsilon naught. And then you will get the derivative, pwede na siya ito bulagon. Derivative with respect to S of ln S minus, di ba, kadumdum ano? kanang distributive ato ang derivative. So, na kay LNS, kini siya nga term class, this can be rewritten as LNS minus LNA. So, na kay the partial derivative of LNS minus the partial derivative of LNA. So, A is a constant. Meaning to say this term will be 0. So we are left with the partial derivative of LNS. So that is equal to, so galing na siya class? Partial derivative of LN S with respect to S, or the derivative of ln x with respect to x, so that is 1 over x, or in our case, it is 1 over s prime. Okay, so this is the gradient of V. And then take note that the electric field is just equal to the negative gradient of V. So we have the electric field is equal to the positive of this one. So lambda is equal to 2 pi epsilon naught multiplied by 1 over s, or this is just s prime. So this is consistent with the obtained electric field kaganina. This one, for a long, infinitely long straight wire. Okay, any questions, class? Class, are you following?
Yes, ma'am.
Okay. So the next problem. Is we have a hollow spherical shell. A hollow spherical shell. So sa difference ani sa katong kaganina. A hollow spherical shell carries charge density which is equal to rho. Rho equals k over r squared. And in the region, r less than equal to b but greater than equal to a. So find the electric field. Find the electric field in the three regions. So these are the regions. R less than A. And then the second one is R less than B greater than A. And then the third one is R greater than B. And then find the potential at the origin. Find the potential at the origin. Okay, so let us draw first the system. So na kay hollow spherical shell. Hollow spherical shell. Okay. This time it has an inner radius of A, and then it has an outer radius of B. Okay. So nadiri ang charges, uniform distribution of charge. Take note, class, that this is a spherical shell. This is not kung atong latawon based on akong drawing kay mura siya og donut, no, but it is not a donut. Mura siya og kanang bola nga baga siya o kuan. Kanang baga siya nga material. So, for example, mo ni siya ang material. So, na siya inner radius A and outer radius B. Okay, and then hollow ning there is a center. All right, so first is to find the electric field in the three regions. So, for r less than a, so it is hollow. So every time gani nga empty space, walay charge, Q enclosed is equal to 0, that means the electric field is equal to 0. So to find the electric field, so we start with region 1 with r less than a. So at this point, your Q enclosed, kung drawing ko Gaussian surface diri sa sulod, ang iyang ma-enclose nga charge diri kung mag-drawing ko Gaussian surface diri spherical Gaussian surface, ang iyang ma-enclose nga charge is equal to 0. Since ang imo ang charge distribution class kay naaraman diri ani ang kini nga region. Okay? So therefore, the electric field is equal to 0. So this is for region 1 where r is less than a. Now for region 2, where r, sorry. Okay, so your r is less than b but it's greater than a. So naata diri na mag-drawing tag Gaussian surface here. If we draw a Gaussian surface here with radius small r. Okay, so unsay electric field diha. Okay, so in order to solve the electric field at region 2, you need to note that at this point, your Q enclosed is not entirely katong the total Q class, no? It is equal to rho, the integral of rho d tau. Okay. So this has spherical symmetry. So our d tau is r squared sine theta, dr d theta d phi. So d tau is equal to r squared sine theta d theta dr d phi. And then your dA, so ito pag electric field, so you just have to equate E dot dA, integral of E dot dA equals Q enclosed over epsilon naught. So we need to find dA also. So kung magkuha ko gamay nga area diri sa imong Gaussian surface, kana siya nga area is equivalent to r squared, no? R squared sine theta d theta d phi. And we know already kung unsa integral anin niya, integral of this. So integral of dA, so we will integrate this one. This is equal to r squared multiplied by kay 2 pi from d phi, and then sine theta
4
d
pi.
theta will give you 2, so this is 4 pi. So you have 4 pi r squared. Okay? Okay, so that is for region 2. So ito, integral of cos integral of E dot dA is equal to Q enclosed over epsilon naught. So naakay E multiplied by 4 pi r squared equals, your Q enclosed is equal to the integral of rho d tau. So naakay integral of rho d tau over epsilon naught. So you have E 4 pi r squared equals, so ito itong rho, k over r squared. Sakto ba? K over r squared. And then your d tau is r squared sine theta d theta d phi dr. Okay, so we can cancel this out. And then we know already the integral of this one. Ang aton na integrate is dr, which is from Ang sa atong limit class? From A to
A
R.
to R.
Okay, so A to R. So we have, ito na ni isulat no? K, this one is 4 pi. Kini siya. And then integral of dr. So R lang no? So R from A to R. Usual. Gina-priman din ni siya sa high class para kuan, ma-distinguish siya sa ato ang limit. Pero parehara man gyapon. So we have K multiplied by 4 pi multiplied by i-substitute na to atong limit. So we have R minus A. Okay. So naakay E is equal to K 4 pi R minus A divided by 4 pi R squared. And then we can cancel 4 pi out. Sakto ba? Okay. And then we are left with this. The electric field is equal to K multiplied by R minus A over R squared. Okay. K multiplied by R minus A over R squared. And then the electric field vector is radial in nature. So this is for region 2. So kitong tunga-tunga sa imo ang spherical shell. And then we have for region 3. Region 3. Region 3. For region 3, R is greater than B. So for this, again, we have to use Gauss law. So we have E dot dA is equal to Q enclosed over epsilon naught. Now, the same naghapon na itong Q enclosed class. Our Q enclosed is equal to rho d tau. But for this, ang atong limit is from A to B. Okay. From A to B. Outside naman
Excuse me,
siya sa...
ma'am.
Yes?
Ang epsilon not, ma'am, mawala siya, ma'am.
Unsa to? Unsa to?
Epsilon not, na kalimot siguro.
Nalimtan na to si epsilon naught kaganina. Epsilon naught, yeah. So you have K over epsilon naught, sorry. So this is epsilon naught. Thank you so much. Isa to. So we can, yeah, you have epsilon naught here. Epsilon naught. Epsilon naught. Epsilon naught. Okay na, no? Na-incorporate na nato si epsilon naught. Sorry kayo. Alright. So we have rho d tau. This time, this is from A to B. So, the same na to ang makuha ang integral. But, so na kay, this is equal to K. Ito na siyang evaluate daan diri class, no? Para i-plug in na lang din nato diretso. So, we have K. Wala pa si epsilon naught diri, no? 4 pi. K multiplied by 4 pi. And then you have R evaluated from A to B. So this is equal to 4 pi K B minus A. So this is your Q enclosed. So you have E multiplied by 4 pi R squared equals 4 pi B minus A. Hindi mo yung assignment, guru class? Assignment mo money?
Yes, ma'am.
Okay. And then you have 4 pi R squared. Alright. So, nonsa naman eh. I-divide na ako siya daan. Limta na po na to ang epsilon naught. So, divide both side by 4 pi R squared. Alright, so we have E is equal to K B minus A divided by epsilon naught R squared. Or we can rewrite this one nga as isa na to ang mga constants, K over epsilon naught. And then this one is B minus A over R squared. All right. And then this is also radial. You have r hat here. R hat. R hat. Okay? So we now have the electric fields, and then after this, we will find the potential. Take note that we will find the potential at the origin. So to find the potential at the origin, saan may na to? So we have V of R, the potential at the origin. Potential at the origin. So take note that sa gikan diri na kay A, B. So from infinity, we want to move from infinity padulong sa origin. So atong i-calculate kung unsa ang potential nga ma-experience kung naa kay charge diri positive charge from here padulong diri sa origin. Okay, so for this, we will separate or we will ato siyang i-separate into three parts ang ato ang potential. So we have, generally, we can get the potential by doing this E dot dl, and then our limit is from infinity towards 0. Tama ba? Sa origin, infinity towards 0. So we can have three integrals out from this. Ito siyang i-separate. So we have E dot dl from infinity padulong kay B. So kung infinity padulong kay B, this is, ang atong electric field is sa region 3. Electric field sa region 3 dot dl from infinity to B. And then the next component is we have from B to A. So for this, ang atong electric field is katong electric field sa region 2. Okay. And then the last one is from A padulong sa 0. So A to 0. A to 0. So this one, ang iyang electric field diri is katong electric field sa region 1. Okay. Now take note that these are all radial. So electric field 1, 2, 3. Radial ni tanan. So our DL here is just equal to DR. Okay? R hat. R hat. So we have from negative infinity to V are E, and so ito itong electric field diri class, K over epsilon naught. Then you have B minus A over R squared. And then your DL is just equal to DR. And then minus the electric field at region 2 dot DL. So you have K over epsilon naught R minus A divided by R squared. Again, your DL is just equal to DR. So this is integrated from B to A. And then the last component is sa region 1, wherein the electric field is equal to 0. Okay. So this is from A to 0. All right, so let us just evaluate these two components sa itong potential since the last component is 0. So, ang mga ganun siya class. So, we have K over epsilon naught. We can actually take out B minus A. These are constants. So, we have integral of dr over r squared from negative infinity to b minus k over epsilon naught lang ato ang mapagawas, no? Since sa numerator kinay r. From b to a, you have r minus a over r squared dr. Okay, so let us evaluate first the first integral. This is equal to, so na kay r minus 2 dr from negative infinity to b. So, unsa ganyan siya class? Plus 1. So, negative 2 plus 1, that is minus 1 divided by negative 2 plus 1. Later na lang ito isulat. Ligo pa ba diri? Negative k over epsilon naught b minus a. And then we have here, negative ni siya, no? Negative 1. So, negative 1, makancel out na ning negative sign diri. So, na kay r to the negative 1, or butang na lang ako 1 over r class. Klaro, klaro pa ni? Multiplied by 1 over r from negative, negative diri class. This is infinity to b. Okay. And then, we continue with the second integral. So, na kay k over epsilon naught. And then, this one, so ang ganun siya class. Pwede ba ito mag-let? Ani? Pwede na siya na to i-separate. So, we have b to a. Ini siya. Di ba, pwede mo na siya na to isulat kining r minus a over r squared. This is equal to r over r squared minus a over r squared. So, the same rin sila, no? So, na kay r minus r squared, that is 1 over r dr. Minus, you have integral from b to a over r squared dr. Okay. So, this is minus k over epsilon naught. And then, integral ani is ln. So, na ako'y ln of r, where r is equal, is from b to a. So, na kay ln a minus ln b, or that is ln b over a. Pero man, no? Sakto ba, class? B over a or a over, yeah, it's a over b. Upper limit. So, ln a minus ln b. So, na ako'y ln a over b. Okay. And then, this one, negative, negative a. Positive na siya, class, dahil, no? Kay r, negative 2 man ni, r minus 2. So, iya ang integral is 1 over r. Negative 1 over r. So, this will be positive a over r. Ay, wait lang. Ay, makalibog. Okay. So, we have a multiplied by 1 over r, where r is from b to a. So, this is 1 over a minus 1 over b. Okay na, class? Na-follow ra ni?
Okay ra siya, ma'am.
Okay.
Yes, ma'am.
Okay, okay. Therefore, madumduman pa ba ni na to? So, natay k over epsilon naught b minus a. So, this is equal to k over epsilon naught b minus a over, sige to, class, over r, b minus a, and then you have 1 over b, 1 over b, 1 over b minus 1 over infinity. So, this is 0 minus k over epsilon naught And then we have here ln. ln of ln A over B. Tapos kini ma-1 na ni siya, no? Positive 1. Ano galing na positive ni siya, class? Positive siya kay ang integral ani no kay A multiplied by negative 1 over R. Okay. So ln A minus B, positive, you have 1, 1, minus A divided by B, minus A divided by B. Okay. Pwede pa ba na ito ma-simplify? Yes, we have K over epsilon naught natay B divided by B. So, i-distribute na ko si 1 over B, class, ha? Minus A over B. This is 0. And then you have minus, na factor out naman ni si K over epsilon naught. So, we have ln A over B minus, no? Minus 1 plus A over B. Okay. So, we can cancel this out. Negative A over B plus A over B, that is 0. And then we have B over B here. 1 more man siya. 1. Okay, negative 1 po diri. So, 0. Ang nabilin is K over epsilon naught ln A over B, which is negative. We can actually switch this, or pwede siya na ito yung positive by switching the numerator and the denominator of kining nasa imong ln. K over epsilon naught ln B minus B divided by A. So this is R. So ganyan niya siya, class. The potential at the origin. Okay. So do you have any questions? Time na, no?
None so far, ma'am.
Ma'am,
Yes.
pwede mo kaya itong kuhan mo, katong last nga meeting?
Oo. Naratog, ipang tigom ra to na ko, class. Pero murag wala ko naka-video atong last meeting. Ang naalang kay lecture notes. Okay, so for your seat work, you have to answer problem 2.24 sa Griffiths. Problem 2.24 sa Griffiths. 4th edition, manggolo to sa Griffiths, class. Okay. So you have to submit this on Friday. Friday na lang. Okay, do you have any other questions, class? So we will continue with katong sa potential, and then work lang ang ikuan, class. I-record. Work. Mahuman lang itanig chapter 2. Okay? Na po may questions? Na may questions?
Wala na, ma'am.